Hey guys, welcome to another math video. For this video, I'll be going over the empirical rule. Okay, so this is what we'll be doing. The empirical rule, we use this in statistics. Okay, so you'll see this a lot using normal curves. Okay, so this is basically what the empirical rule is. Let me go over parts of this graph first. So like I mentioned, normally we use this with normal curves, that is symmetric bell curves. Okay, so right here in the middle is our mean. This is the Greek letter mu. We use this to mean population mean, and I'll go over that in a different video, so don't worry about that too much. Just know that this symbol right here means mean. Okay, this symbol right here that looks like a little circle or a little O with a hat, that is a lowercase Greek letter sigma, and we use that to represent standard deviation. So this is 1 standard deviation, 2 standard deviations, 3 standard deviations above the mean, and the same below the mean, okay? So up here are the numbers I want you to kind of pay attention to. So the empirical rule uses these estimations. So within 1 standard deviation, and you'll hear this if you take a statistics class, whether it's an introductory, introductory, intermediate, or an advanced statistics class. The latter two, intermediate and advanced, especially, they'll expect you to know what that means. In the introductory, you get to see what this means in the beginning because you're being introduced to it. So when your instructor says within so many standard deviations, they mean that many standard deviations above and below the mean. Okay, so in this case, within 1 standard deviation means 1 standard deviation above and 1 standard deviation below the mean is going to contain 68% of your information. Okay, so from here, 1 standard deviation below to 1 standard deviation above your mean, and this whole area right here, it will contain 68% of your data. Okay? Now within 2 standard deviations, so from 2 below to 2 above, this whole space right here is 95% of your data. And within 3 standard deviations, so from here to here, this whole area contains 99.7% of your data. So of course under the whole curve is 100%. Okay? And if you're only going up to your mean, remember the mean's in the middle. Middle is halfway, so either side of the mean is 50%. Okay, now all these different numbers here represent the different breakdowns in between each of these percentages. So if the middle here within 1 standard deviation is 68%, if you split it down the middle, you get 34% on both sides. Okay, now 95%, right? If you split that down the middle, you get a combination of these two, 47.5% on both sides. Okay, and then 99.7, you split that down the middle, you get a combination of all of these three, which is 49.85. Okay, so it's not numbers you have to memorize. Well, not all of them anyway. The only ones you really have to memorize are these three here. Those are your main ones. All the other numbers you can get from just splitting them up. Okay? It does help to have these numbers. And you're probably wondering how they got all these numbers in the first place. Well, after years and years and years of research, statisticians or researchers noticed that these patterns started forming. So it wasn't exactly 68%, 95%, 99.7%. It got pretty damn close. So they rounded up for the most part. Okay, so after seeing all these patterns, they finally said, okay, within one standard deviation, most of the data is there, 68%. No, it's not most, but a lot of the data is there. Within 2 standard deviations, 95% about. And within 3 standard deviations, almost all, like 99.7%. Okay, so let's take a look and see how we can use the empirical rule in a problem. Okay, so I'm not going to give you like a whole story. Most textbooks and online programs will do that for you. I'm just going to use the last part. So using the graph of the normal curve, use the empirical rule to estimate the area within 1 standard deviation. So that one was easy. We went over that already. So within 1 standard deviation is 68% of your data. Okay. B, more than 52. So 52 here is our mean. So the mean is right in the middle. So we were looking at this half, right? 50%. Okay. And C, less than 34. So here's 34. 34 is 1, 2, 3 standard deviations away. So between 34 and 70%, well, it's not 70%, sorry, 70. Between 34 and 70 is 99.7%. Now we want the portions on the outside. So we take 99.7% away from 100. That leaves us with 0.3%. Now that's on both sides, but we're only concerned with this half. So we're going to take half of 0.3%. Okay, so 0.15%. Okay, and I don't know what you're thinking. That was pretty simple. So what if we had an example that was a lot more, well, involved more thinking? Well, let's try this. So we're using the same data, but this time it's asking different things. Okay, so A is asking for the area between 46 and 64 this time. Okay, so here's 46 and here's 64. So 52 is still in the middle. 46 is 1 standard deviation away. 64 is 2 standard deviations away from the mean. Okay, so we'll start with 46 first, since that was the first number. So 46 is within 1 standard deviation away from the mean, but we're only looking at half of it. So we want half of 68%. That's 34. Okay, now we look at 64. 64 is 2 standard deviations away, but we only want half of it again. So half of 95 is 47.5. So those are the 2 numbers we're going to be working with. Okay, so now to get the total area, we're just going to add these 2 numbers up. There we go. Okay, so now B between 58 and 70. Okay, so here we go. So this one's going to be a little bit weird. So what we're going to do is we're going to take the total area from all the way to the far left up to 70. So as you recall, 70 is 3 standard deviations away. So between 3 standard deviations, or within 3 standard deviations, is 99.7% of your data. But we're only going to use this half because we're adding the whole thing on this side. This 50% is being added to this. The half of the within 3 standard deviations. So half of 99.7% is 49.85%. So we're going to add that to 50%. Okay, now 58 here is within 1 standard deviation. And again, we want to find this whole area here, because what we're going to do is we're going to subtract this whole area all the way up to 70 with this whole area all the way up to 58, so we get just the portion between 58 and 70. Okay, so we're going to take half of 68, which is this portion here, because we only want this half, and we're going to add it to this whole half here, the 50%. Okay, so this is what we're doing. So we're taking 50% up to here, and we're adding it to half of the 3 standard deviations. Then we're going to subtract the 50% added to the half of 1 standard deviation. Okay, so we simplify that, and then we just subtract. Okay, and then the last one here doing 34 and 52%. Okay, so we want just the area between here and here. Okay. So this is what we're doing here. So up to 52% is half, right? 50%. And we just want to get rid of this portion here. So if you remember from the last problem, this portion was just 0.15%. So we do the subtraction because we only want the portion between here. We get 49.85%. Okay, so this one was a little bit more complicated. Still using the same information, it's just asking slightly different questions. Okay. Okay, so that's pretty much it for this video. I know that second one was a little bit more confusing, so if you want to go back and take a look at the example one more time, or as many times as you need to, feel free to just rewind. If you got any questions, leave them in the comments. I'll get back to you as soon as I can. Otherwise, thanks for tuning in, and I will catch you next time.